Performance testing of asphalt mixtures is an important aspect of performance-engineered mixture design of asphalt. It helps improve performance and prolong service life of flexible pavements. This video is part 3 in a series of 4 videos on asphalt testing using the Asphalt Mixture Performance Tester, or AMPT. This video demonstrates the Cyclic Fatigue Small Specimen test based on AASHTO TP133. All AASHTO standards mentioned in this video are private voluntary standards and are not required under federal law. Before beginning this test, you should prepare the test specimen to the target air voids as recommended by AASHTO PP99. Refer to video 1 in this series for more information. Also, attach gauge points to your small specimen. This procedure is covered in video 2 on dynamic modulus testing. Before you begin the cyclic fatigue test, attach platens to your test specimen using a gluing jig. Supplies and materials are shown here and include acetone, cotton swabs, wooden mixing sticks, mixing pallet, 38mm diameter small-scale test specimen with gauge points installed, scale, and glue. Start by cleaning the contact surfaces of the 2 metal loading platens with acetone. Install the platens in the gluing jig, then place the specimen to check for eccentricity. If there is no eccentricity, remove the specimen and the platens and proceed with gluing. If you observe eccentricity, adjust the gluing jig and check again. Prepare approximately 6 grams of adhesive. If using an epoxy, proportion and mix the resin and hardener together in accordance with the manufacturer's instructions. As shown in this example, apply 1/3 of the glue to the contact surface of the bottom platen. Next, apply 1/3 to the contact surface of the top platen, then install both platens. Apply the remainder of the glue evenly to the top and bottom of the specimen. Install the specimen in the gluing jig in such a way that the gauge points on the specimen and the holes on the platens are not aligned. If they are aligned, you may accidentally dislodge the gauges when attaching the specimen on the AMPT. Rotate the top platen slightly until the glue begins to ooze or seep. Use a mixing stick to remove the excess glue. Secure the specimen and allow the glue to cure based on the manufacturer's recommendation. Throughout the cyclic fatigue small-scale specimen test, refer to the current AASHTO recommended standard. Supplies and materials for the test are shown here and include 2 spacer platens, LVDT sensors, LVDT clamps, screws with washers, 38mm diameter small-scale specimen with gauge points and platens attached, dummy specimen with thermocouple thermal probe installed in the middle of the test specimen, hexagonal or Allen wrench, and metal shims. Place both the testing and dummy specimens in an external environmental chamber. Leave them in the external environmental chamber until the dummy specimen reaches the test temperature. Open the AMPT conditioning chamber to prepare it. First, install the lower platen. Use screws and washers to secure. Tighten the screws uniformly with the Allen wrench. Next, use screws and washers to install the upper platen. Be careful not to over-tighten this platen so it can rotate during the assembly. Install the LVDT sensors on the equipment. Close the AMPT conditioning chamber and set the temperature control to the desired testing temperature. Allow the AMPT conditioning chamber to stabilize at the set temperature. Once the dummy specimen and the AMPT have reached the designated testing temperature, remove the testing specimen from the external environmental chamber and attach the LVDT clamps. Make a note of the time before opening the external environmental chamber to calculate the specimen installation time. Open the AMPT conditioning chamber and set the specimen on the lower platen and secure with screws and washers. Tighten all screws evenly. Once the screws are tight, slowly raise the specimen. In the control software, make sure the initial seating load is set to 10 newtons, then raise the actuator. Align and attach the remaining screws and washers to the top platen. Verify alignment, but do not tighten the screws completely yet. Check the gap between the loading platen and the top platen. If the maximum gap is greater than 0.8 millimeters, discard the test specimen. If the gap is between 0.8 millimeters and 0.05 millimeters, insert shims to fill the gap. If the gap is less than 0.05 millimeters, continue tightening screws without inserting shims. To fill the gaps between the loading platen and the top platen, insert the thickest shim possible into the maximum gap without using excessive force. Insert 2 additional shims on each side of the first shim as shown in the graphic. Now, tighten the upper screws uniformly. Start with the screw opposite of the maximum gap. As you tighten, be careful not to apply torque to the sample or over-tighten the screws. Reduce the seating load to 0 newtons. Install the LVDT sensors. Once the sensors are installed, ensure the LVDT readings are adjusted to accommodate the deformation range of the cyclic fatigue test and compression fingerprint test. The cyclic fatigue test deformation range is expected to be higher than the fingerprint test. Close the AMPT conditioning chamber and make a note of the time. Calculate the installation time, which is the time between opening the external environmental chamber and closing the AMPT conditioning chamber to install the specimen. Using AASHTO TP133, determine the AMPT conditioning time for the specimen in the chamber before starting the test. To start the cyclic fatigue test, select AASHTO designation TP107 or TP133 on the equipment control software. If AASHTO TP107 is selected, the equipment should be fine-tuned for small-scale testing. Enter the project name, operator, test identification, specimen conditioning time, and properties such as air voids. Input the diameter and height. Make sure test frequency is set to 10 Hz and the testing temperature and axial gauge length are correct. Enable the dynamic modulus fingerprint test. Set the target strain range between 50 and 75 microstrain. The estimated initial modulus should be underestimated. Modulus can be estimated from the dynamic modulus test. Select direct tension test where the target peak-to-peak microstrain is fixed at 450, but it can be changed according to the dynamic modulus fingerprint. Enter the maximum value for number of test cycles. Enable rest period and apply 0 load. Select automatic start after the 20-minute rest period. Select start, dynamic modulus fingerprint test, and then select a location to save the data. The AMPT will calculate the load level necessary to achieve 50 to 75 microstrain using the results of these first few cycles, and then apply this load level to 50 cycles. According to the current AASHTO recommended standard, record a minimum of 50 data points per cycle. The test specimen will rest at a 0 Newton load for a minimum of 20 minutes following the fingerprint testing. Perform the cyclic fatigue test at 10 Hz using a strain level that will result in a test length between 2,000 and 80,000 cycles. Allow the test to run until a clear peak in the phase angle versus number of cycles curve is observed. The test stops automatically when the machine limits are reached or the test reaches 80,000 cycles. Once the test is complete, open the AMPT conditioning chamber, remove the LVDTs, and lower the actuator if necessary. Remove the LVDT clamps. Remove the screws from the lower platen and take out the bottom part of the specimen. Loosen and remove the screws from the upper platen and take out the top part of the specimen. Examine the crack pattern of the tested specimen. If the specimen breaks between the gauge points and end platen, the data should be discarded and the test repeated on a new specimen. Exclude any test with a number of cycles to failure greater than 80,000 or less than 2,000 from analysis. Repeat this process on the remaining test specimens. For more information about Asphalt Mixture Performance Tester procedures or other pavement testing resources, contact the Federal Highway Administration.